So actually, Laurent, me, myself, we started with Ethereum in 2015, and we created we were like 8 people really interested into Ethereum, and we met every Sunday discussing it. And then we started doing meetups, like the DAO hack, Gnosis, and all this, but mostly to learn. And last year, somehow, we realized there's a new topic coming, which is cryptoeconomics, which I will present shortly what it is. And now we have some ways to connect, because the idea is not only speak about decentralization, we also want to actually practice decentralization, and this also in the way we learn. So I don't know if you have Telegram, but hello. We have a group in Telegram, and we also started now every Sunday from 5 to 6, we do online sessions with people from all over the world. So there are also people from India, from Belgium, from France. And the concept is like it's a 1-hour session, so it's short, but it's every week. And Laura and myself, we are the moderators. But you can also be moderators. So if you write us and say, I have a project I would like to present which is connected to cryptoeconomics, you can obviously do this. But it has to be topic related. It can't be ICO promotion, obviously, okay? So therefore we have something like moderators. You can join there. We opened up a Discord, which is similar to Slack, if you know Slack, but it's not so restricted. So, and it's actually a server. And there we started sharing content, because cryptoeconomics gets bigger and bigger and bigger, and just having everything in one Telegram group is not working. And what we will do now, so this is obviously a meetup event, but we will do like crypto minis. So we do now every week, also here in the International Lab, also 1 hour, but this will be in Spanish. So everyone who's more familiar with Spanish can come there. And we will do the same thing then in the online sessions. So Laurent and myself, we will prepare content. For example, we do like an introduction to behavioral economics, for example, and how this is related to crypto, and then we discuss it. But in these sessions, because they are weekly, only 10 people can come. So the first 10 that sign up are in, let's say. And maybe you know this from other meetups, so if you sign up, please also come. And if you don't come, then delete this. Bless you. So these are the ways how you can connect with cryptoeconomics in the future. And as I said, this presentation is online, and I won't speak a lot because I want to we want to have that Severin speaks the most. But just to let you know what is cryptoeconomics, so it actually started in 2015. Vlad Zamfir, who is a core developer from the Ethereum Foundation, he put it into, this is actually the definition of economics. So economics is actually a study, which is said here, about the production, distribution, and consumption of goods and services between humans. But the difference in cryptoeconomics is that it's handled by protocols. So it's not handled by entities or by governance or by whatever. It's actually handled by protocols, and it's decentralized. And this small word, decentralized, changed everything. Okay, because suddenly we need autonomous mechanisms that make it work. So we don't have like a central bank anymore, or a state who can just decide in every moment, now we will make this, now we change, now we vote. So we have to create these mechanisms, and this makes it a little bit complicated, but so much more interesting because everyone can join. And the word cryptoeconomics, as you see, is actually a combination of 2 parts. So you have on the one hand crypto, and crypto is always related to cryptography, okay? And in this sense, so cryptography is super useful in a decentralized, anonymous world, because the problem is, suddenly, how can we provide evidence in this world? You know, in our current world, we do it via email verification, we do it when we travel, we have ID, passports, but in this world, we don't want this. We actually want to stay anonymous. So how can we give evidence of our identity, of property, of whatever? And therefore, we use cryptography. Because if you join this space more, you will learn about public and private key and hashing. This is like the basic, okay? If you join here, like hashing will be like hello, yeah? It's the word you hear the most. And these cryptographic evidence we can use to give, to show what happened in the past. Okay? So I can show with this all happened and no one can deny. No one can say, no, this didn't happen. And then you have economics, which is actually referring to incentives. Because with incentives, we can manipulate or we can choose the direction in which humans will behave, and then in this way we can somehow predict what will happen in the future. But, and therefore I said in the beginning, behavioral economics, humans are not machines. So sometimes they are not rational. So what is in this economics part of cryptoeconomics is game theory, mechanism design, but also behavioral economics, because sometimes we have the situation that humans are not rational, and this we need to understand also. And what are incentives? Well, at the moment, the most common ones are tokens and privileges. So if you give, like miners in Bitcoin, if you tell them you get 12.5 Bitcoins, there you go, okay? You have an incentive that they mine. But you can also give people privileges, so that they can do certain things other people can't do. And you can take away both. And by these two things, you can already manipulate how people will behave, okay? And so cryptoeconomics is like a new field. It's a somehow academic field. And there are already research groups. And there's actually already a university offering a whole master program only about cryptoeconomics. And if you want to know more, you can contact us. We have as we said, we have a course. And just shortly, so here you see that's all the elements. Then you have some research groups. Consensus protocols is one application where we use cryptoeconomics, actually the most important one. Then everything needs to be checked by attacks, but attacks means not programming attacks or software attacks or something like this. It's actually game theory attacks. Okay, that's a really interesting topic. Then you have state channels, so Lightning Network, Radio Network works also based on cryptoeconomics, on the idea. And obviously, so all the new projects, all these token designs. So we have like, at the moment we have like ICOs mainly have an idea and a team, maybe. Okay, so the white paper and the team is always who is in it and what did they write down. And the next version will be a lot about, so what's actually their mechanism? How do they want to actually make this idea happening? And there are some projects that actually already understood that we need quite a complex thinking, so you will speak about complexity. And we analyze these token designs. Yeah. Okay, so that was a short introduction.
Hello. Thank you for being here today. So quick introduction, follow up on what Sandra was saying. We have studied a lot in the past year or so, I think, about cryptoeconomics and all the foundations. And I think now we see a little bit more clearly what it's all about and what can we do with it. The thing is, the field, as I tried to show you here, is really, really new and unequipped for, say, the amount of money that is being managed in the sector at the moment. And so, by focusing on cryptoeconomics, which is the fundamental part of every project, blockchain, the foundation of blockchain inside of the world, we want to expand on these foundations and give an overview, or maybe a more structured understanding of cryptoeconomics at large, and where can we go with it in the future. And so, getting back to what cryptoeconomics is, and what Sandra just explained, game theory and cryptography are the two fundamental elements. But what we're trying to achieve with this is to find a new way to establish or to propose social order, right? Which is the foundation or the idea of any society, really, to align people around some shared idea about what they're doing here together and where they want to go with it. And so all this bit is about that, and understanding how people are taking decisions based on their intervention and the incentive that they have to do so. And there are many different aspects that kind of, aspects that are not normally included into this kind of discussions, such as psychology, anthropology, sociology, and so on. And this, as behavioral economics, for instance, is economics and psychology, while there are several other aspects that we want to bring to the reflection, to the question we are raising here, to understand a little bit better how are we really going to create this new world with blockchain, right? And even if you think about macroeconomics, we reasonably understand today in this world, well, what's the equivalent in the blockchain world? If, say, everybody is using it, or every business is based somehow on blockchain, then how all these projects are going to connect to each other, and what's the general outcome for a society by using those tools. The interesting aspect is that in itself, those projects, like Bitcoin, if you will, the first one, they almost started to take some life aspect, if you will. They are autonomously doing something on their own, and they don't need us to do that. So the intrinsic function of or the objective, the objective function of Bitcoin, right, is to make people mine Bitcoin. And it's very simple, it's like that, and it depends on two factors, and it works. So they actually, or Bitcoin has actually managed to make people do something for it. Just like, wheat, you could say, wheat has managed to make humans grow it. But which one is in charge? We don't really know, right? Or at least we think we know, but we don't. So, another interesting aspect, of course. Then if we go into different structures that we can see, so we see blockchain stuff and DAO, which is the summary, if you will, of any projects in the sphere. Blockchain is really using cryptographic game theory to build consensus mechanisms, but in DAO projects, you use cryptography, of course, but reverse game theory to define mechanism design. Right? And this is the key part. The mechanism design is really, it's not new, so it's an old discipline, if you will. It's not new, but it's new in the sense that we don't really know how to use mechanism design to manage such a big activity, big economic activity as well. And so this part, the mechanism design, and the way it can be structured is also another, say, foundation or pillar of what we want to do in those new learning sessions and online stuff that we'd like to do. To get a bit more sense of, is there one specific mechanism that will always produce the same outcome, and that can be like an off-the-shelf kind of technology that you can implement in your project, and you know it's going to work because it has been proven by some mechanism design. And the third one would be, okay, so once we've got all those ingredients, we'd like to start building stuff, right? And at the moment, this is really the state of the art of the tooling, that we have at hand. We are trying to make some trial with 2 pieces of wood with it. So not only do we not understand clearly what are the mechanisms and how do they work, we don't know really how to prove things. So, like, what kind of modeling tools should we use to demonstrate that one specific mechanism is actually working the way it has been intended? How do you verify your methodology? How do you verify that the results that you're getting are actually scientifically proven? And yeah, and how do you then create a methodology for projects to follow? How do you establish like some standards of development, of modeling, of testing, and how do you iterate on those to actually start having a sector that is more equipped and more professional in the way things are being done? So this would be the third step we'd like to do something about. And with that, then we can start thinking, okay, so what are the token flavors or the token designs that we have, and why this particular kind of token should be understood that way, and it becomes always going to work, and you can actually maybe mix some different tokens with different properties to achieve what you want to achieve. Because, and then I go back to the first part, which is the social order. So all those things I've been talking about will be used into a broader reality, which is social order. We're trying to align incentive of different participants that don't know each other to do some work or to produce some outcomes that we like to produce. Right? So this is and the token part is using mechanism design, obviously, but there are many flavors, right? And this is also something that is not standardized yet, right? And we'd like to do some work on that part too. And with that, I leave the floor to Severin, and we let you introduce yourself if you don't mind.
Okay, yeah, first of all, thank you for having me here. It's beautiful city, beautiful weather, so thank you very much. Sandra invited me to come here and talk about the things we do in Düsseldorf, or talk about a bit of the topic of blockchain, cryptoeconomics, and the space in general. My name is Severin Deutschmann, and I worked as a consultant in this space, and I'm a speaker. I go to universities and talk about people on the topic of blockchain because I think it's really, really important for people to get educated on this. It's going to be really relevant, especially for the people that are now deciding where they want to go in life. So this is really important for me. So I love to go places and connect with people and make natural connections with all the networks and organizations we have. So what am I going to talk about? The talk is called Complexity Rising, 3 short stories of the evolution of complex systems, right? So I really like what Doran, right, was saying. He said, first thing he said, I remember, was Bitcoin already has some life on its own, and I would totally agree. We will talk about life in a few minutes. And the question, what is the game? I think this is a really good question, and this maybe explains, because I'm going to start not with blockchain or crypto or tech, but with physics and entropy and the universe. And because the framework I'm thinking about this is I try to connect all the different disciplines or get an insight on this, and this is basically the question: what is the game on a much broader sense? And for me personally, I got some insights that I want to share with you that for me seem valuable, and hope you can take some inspiration with this for you. So without further ado, let's start. Part 1, a short story of entropy and complexity. Entropy is a really complex topic to get your head around, and it's really a challenge to who in this room has heard the word entropy or knows what it is. Okay, this is good. So there are lots of different ways to explain it. You don't have to grasp it 100%. You will get a rough idea that will be sufficient for this talk, but just to start with one definition. So entropy is a fundamental function of state of a given system, right? So when we talk about blockchain, we talk about states as well, and entropy is basically a function of the state of the system. And in its most basic form in physics, entropy is through thermodynamics is defined as there is a maximum state where you have an equilibrium. So a classic example is I have cold water and I have hot water, and I put them to each other, and And over time, they will exchange the heat, right? And both will become the same temperature. And once they reach the same temperature, we have reached the maximum amount of entropy in the given system. And there's this rule, it's the second law of thermodynamics. It says lots of things, but one of the things it says in this context, or what entropy in general says better, is in a closed system, entropy will always rise to a maximum. And as entropy is a measurement for disorder, the disorder will increase. So what does this mean? In the beginning of the universe, the entropy was at a minimum. And in the end of the universe, the entropy will be the maximum. This will be when time ends and when everything will end. And in the beginning of the universe, the complexity was 0. And in the end, the complexity will be 0. But the interesting thing is, what we right now see, we are human beings. We have order around us. We ordered and we keep on ordering the world around us. So the interesting thing is what is happening in between. The complexity rises and the complexity goes down again. And to give you an example, entropy on a macroscopic scale is basically saying I have a house, and if I don't put any energy, new energy in the system. So if this is a closed system, nobody gets to the house and it stays for itself and will degenerate over time, right? But if I don't assume it's closed, right, then people can go in, put in energy, put in work, and keep on restoring this structure and keep it orderly. So they fight against the disorder. This is what all life does. This is all what we do. So our bodies are constantly degenerating, and we eat things and take this energy and this matter to rebuild ourselves and keep on living. So life is basically a fight against entropy. And then there's this concept of complexity that is that goes together with entropy, right? And there is no consensus on complexity. There's not that one definition you can use because it's such a broad term. But I think it's a compound word of com for together and plex for woven. So it's about interwoven systems, right? And a system is then complex once you get feedback loops and stuff like this. And this is really important for game theory. This is important for systems thinking, biology, economics. All these things are complex systems, and therefore you need something like system theory or a system design thinking or a system thinking mindset to wrap your head around it. Complexity is generally used to characterize something with many parts, where those parts interact with each other in multiple ways, culminating in a higher order of emergence greater than the sum of its parts. Emergence is something really, really interesting for this whole topic, because you say we have microstates, right? We have rules of behavior in simple systems, but once we multiply all these systems, we get on a macro level, we get new structures that weren't obvious from the beginning. So it's like having ants in a colony, right? And the ants together and how they work and the network and the rules they behave by result in a higher order of complexity, or in new structures they arrange themselves, and they can handle things as a swarm that the single ant couldn't handle, right? So this is a good example why this is so elementary. Do you know where all the complex matter comes from? Everything you are and everything you see right now is complex matter. And complex matter comes from dying stars. So you take a star, you have helium, you got Wasserstoff, what's it called, the H1, hydrogen, yes, hydrogen, gotta know your period system, right? So you have hydrogen and you have a huge bunch of this, right? You get this stellar nebula, and then you have this thing called gravity, and it gets to the star. Let's take an average star like the sun. And then you have something called fusion, where these both atoms, they are both 1 and 1, right? One nuclei, they crash together, and when they come together, there's some energy that is freed up, and they get more complex. We get helium. And this keeps on going until we get to a critical point where there isn't any more hydrogen or not enough hydrogen to keep them adding, and we get, for example, a hydrogen and a helium in a simple way that fuse together, and we get more and more and more. This is when the red giant happens, right? We get some more gravitational forces inside, and he shifts in things, and then he explodes, and he releases complex elements. So in the beginning, we have a state of low entropy of simple systems interacting, and the result is new complex structures that are stand at the end of this process. And this process is what is happening everywhere, and this is like one of the most fundamental processes. You have here, this is from the NASA, this is from a really interesting research paper where they think about how to colonize new space systems. So it's really interesting if you want to build something new on Earth, there's interesting stuff as well, right? Because they think civilization through from 0 to 100%, right? So in the beginning we have the Big Bang, low entropy, and we see entropy increasing towards the maximum, right? But then we have these things. This is what I described, the process with the stars. It's light elements, it's hydrogen, and over some time we get heavy elements. They are more complex, right? And in the end, we are the result of these complex elements. Without these, we wouldn't exist. So there is this complexity that is working seemingly against this tendency of entropy. And at some point, we get life. And at some point, we get human brains. And the prediction for the future, or what we already have, is intelligent matter. So this is intelligent matter. You could argue, or you could say this isn't intelligent matter yet, but there is a good argument to be made that this will turn into intelligent matter. Entropy is basically an engine for life. That is the reason we have these things. So we have high potential energy and chemical bonds, and this is how life could have started, right? We have this high potential energy, and there is a process how to get to this energy, but the process is rather complex, right? So in the beginning of life. It's hard that this happens by chance, but if this happens by chance once, and it's a replicatable process, for example, what RNA was doing in the beginning, based on some thesis, this process will keep on going, right? So maybe there's a low chance this will happen, but once this happens, this keeps on happening. This is basically what complexity is, right? It's like having a unique thought that nobody has ever thought about, right? Or making something new and unique. You make something new that makes the world we live in a little bit more complex, and all that it needed was basically time until somebody did this new thing. And this is the same for all the new inventions we have. These are all new things that increase the entropy in life. At some point we got something like this RNA world. And then this is from biology, and these are called major evolutionary transitions. We are humans, right? We can agree on this. But we are not only humans, but we are also colonies of cells. And cells are not only one entity as well, but cells have DNA and RNA, lots of them, and other cells, because they're multicellular in themselves. And even RNA, you could argue, has another form of life underneath, like these simple structures. So we are several layers of collective things already, and you could go one layer upwards and say we as a human society are already one organism, because you can look at it this way. And this is how all these things happened on a micro level, and we can look at this at a macro level as well. First, we have solitary individuals working for themselves, or we have solitary groups like tribes. And at some point, we have cooperative groups. They get together, like one tribe focuses on fishing, the other on hunting, and the last one, getting some rocks or metals, because they have the better local situation. Then they start to trade, right? So they are in a loose cooperative group. And at some point, when they decide to specialize on this and form a new entity, we get a new higher level individual. This is basically like the cells that we evolved from, right? We are now one higher level individual as well. And I would make the argument that the process we are in right now, in some way, is we are at this point as a human society, and we are moving to this one. So we are evolving new systems that help us to collectively control and organize the cooperation on a global level, on a human species scale of level that we haven't reached yet, obviously. This is again how life works, and I think this is really interesting. We have this evolutionary substrate thing, right? It started with just simple chemistry, RNA, DNA. Then we have cells, right? So we get from chemistry to biology. And then something interesting happened. We got human evolution. This is something we can identify with because we are humans, right? And the interesting thing with humans is that we outpaced evolution by orders of magnitude, right? I mean, we still have basically our primitive brain structure, and we have this primitive models in our head, but we evolved to such a complex high society, and we did this through culture, right? So culture took on the torch of increasing complexity, right? So in the beginning it was just stars burning and dying and creating complex elements. Then on Earth it started with simple chemistry. At some point we got this thing called evolution on a biological level with random mutations in DNA structures. And all of these processes were faster than the one before, right? Then we got culture that is really, really fast. If you look at it, maybe like 12,000 years, like we are building structures around ourselves, right? And this was really fast and outpaced evolution by margin. And now we see technology, like we are like everything around us is already complex. We erected these order structures, and now we start erecting new order in digital systems, right? The complexity keeps on rising, but on our phones, everyday new content, new groups, new ways and modes of information exchange, right? So, yeah, and to show this again, if you see this one, like, this goes like, this fits really well with this, again, from life to human brain to intelligent matter. It's basically the same theory, even though it comes from two different fields of research. This is scale of humans. It's a logarithmic chart from this 12,000 years ago, and you see how the human society keeps on rising and growing because of the complexity. We get better systems, more efficient systems, and we get more together. The scientific advancement follows the same thing. We can basically ignore these thousands something years of Christian dark ages, because in the end we still keep on rocketing through the roof, but it would certainly be interesting to live in a world where we didn't have this. And this is the same thing, like who knows more the Moore's law? Yeah? So I would argue this is exactly the same process again, right? It's complexity increasing. It's a universal process. It's really rooted in the beginning of the universe and will continue until the end of the universe. So for me personally, I think this is something really elementary, and all of these things, they really fit well together. And so now we are at part 2. This was just a rough overview. You don't have to understand everything from this, and maybe I didn't explain everything like really good and really well, but are there any questions at this point? Okay. So the next chapter is Rise of Complexity and Human Civilization. This is basically what I took from an article that's really, yes?
Well, if you mention it, I get another question. So, will you see complexity decrease within society at some point?
Yes, once we start. So if, for example, if we destroy ourselves, then so if we don't have enough energy that we can keep the order we have erected, because there's so much work we have to put in and keep structured, and if something huge happens to us that makes us collapse, maybe we use up some important resources for our whole supply chain, or we destroy our environment, because we're interwoven with this as well. If we reach this point, this will certainly go downwards, and I think this is where this trend can, like with the Dark Ages or something like this, can come to a halt. And this is the interesting part, like you don't know when you hit the top. And right now, we only know humans. There is no other thing more complex than us. So if you think about it, we are basically at the forefront of an evolution that started 13.8 billion years ago. And if we manage to destroy ourselves, and if we are actually the only living things, we destroyed something the whole universe winded down 13.8 billion years for, just because we couldn't manage it. So I hope this is one of the goals, one of the things that motivates me, just be a part and help, because I truly believe this technology can help us coordinate in a better manner and face those challenges together, right? That we are actually the generation that reaches the tipping point of the complexity, but rather I want to be here and have some more generations that keep on seeing new things and keep on building new stuff.
It will depend if we have new Christians, right?
I'm sorry?
It depends if we have new Christians, like that.
Yeah. Yeah, so better don't feed the Christians, no. Yeah, let's keep on going with the rise of complexity and human civilization. So again, this is a paper. And the interesting information is for you that are a little bit in blockchain, you will start to see why this is interesting and how this connects. Keep in mind this paper is from 2002. So there was no blockchain around, and they did some predictions that fit perfectly well to the times we live in now, like 16 years ago. So there are these things. So what we're going to do is basically try to make a complexity profile analysis of the evolution of the human society. And for this, we have some tools in our hands. We have this thing. And on the left, you see random behavior, coherent behavior, and correlated behavior. Where sometimes I mix them around because they sound similar. And on the bottom, we have physical, biological, and social spheres, states, levels, layers, whatever you might call it. So just to go through this example so you get a good grasp of these concepts. Random behavior is on a micro scale. I talked about micro scales, right? It's when gases move randomly around, when a crowd is randomly moving around. And if there's no goal, then if you look at it from a macro perspective, then you see no movement. Like pond life, some things moving around crowds. Coherent behavior is basically saying, okay, we define a coherent movement as all the parts moving together in one direction. So this could be on a physical level the cannonball. He's moving and every atom is moving with it in the same direction, right? So we get some behavior on a bigger scale, because on the scale of the cannonball. We have this with infections, right? They have a goal, they know where they want to go. They are simple systems that collectively go for one thing and organize this and reach this goal. Then we have armies, right? We have lots and lots and lots of simple elements, like you take this weapon, you run there and you kill everyone you see, right? It's a simple order, and if everybody does this together, you get a higher magnitude. You get an army, not a soldier, not a fight, you get a war. And this is something on a different scale happening. And then you have this thing called correlated behavior, and this is actually interesting. This says basically, I'm looking what you all are doing, or I'm maybe if I'm consciousness, I'm aware of my surroundings, or if I'm stupid, like in a snowflake, it's like I correlate with my surroundings. So it could be, so it doesn't have to be that all go in the same direction, but the direction I'm going depends on my environment. So I take my environment in and then decide on a direction. So we get these correlated behaviors, right? So why am I telling you this? So the complexity profile is exactly this. If we take this pond life, we zoom out on another scale, we see how this behaves, right? In random behavior, it's really simple. On the microscopic level, we see this random behavior. One layer upwards, it basically stays in the same thing. It doesn't move in any direction. And one layer over there, we don't see anything either. With the coherent behavior, it's already becoming, you see that we get the macro behavior on a scale over that, right? And it's like on this scale, on this, it gets basically like, you can see it as one single part again, because all of it is moving. This is what we do in physics as well. If we try to calculate the cannonball, we don't calculate each atom, but we calculate the cannonball as one whole, because we can do that because it is in a correlated behavior. And with the coherent behavior, you have this thing with the complexity profile that it can actually basically like can either decide or it has some complexity in the macro scale behavior it can show you, right? And this is what we want to go for more and more. So this is the human complexity. This is the complexity of yourself. It's on an atomic, molecular, cellular, human, and societal level. And then we have the complexity individual. That's exactly this point here as a orientation, right? So on an atomic level, you are really, really complex, right? To measure every atom from you and put them together to make you really hard. You need a lot of information to save this, right? And then it gets better to the human part. And on a societal scale, okay, right now we are already more globalized and complex, but the human itself, on a societal scale, is obviously not that impactful and not that complex for that society, right? I mean, you can do lots of things as a human being, but not increase the complexity of society at all with it. So this is how society organized itself. In the beginning, we had something like tribes. I had somebody, he was the leader of the tribe, right? And he said, we're gonna go hunt there. There's gonna winter coming, we move there. And if you're gonna take the right decision, the people move together. And if he does the wrong decision, he dies, and we never hear about him again. And then we get to something like with the Egyptians, right? They were a real civilization. They built monuments. They built pyramids, right? Building pyramids is obviously a more macroscopic behavior of a society, not of a single being, right? But how could they do it? They could do it because they had slaves that you could give really simple order, right? Building a pyramid with lots of slaves is not that hard. And you just need some overseers that can look after like 50 or 100 people. So we have a few overseers here, and then you have the pharaoh or someone at the top, and he says, I want a pyramid, make it this shape, and then they build this for the next 100 years, but they actually built it, right? And this works with this control structure, right? But if we get into a more evolved society, in the Industrial Revolution, what we had to do, we had to maybe increase the branching ratio, is the correct term. Basically saying we increase the amount of management positions in between, so we can have more localized decision making on certain topics, and the information flow in the hierarchy is better organized. But this is just in a perfect model of a hierarchy. In a perfect idealized hierarchy, the maximum amount, because all the control comes from the top, from one single source, right? So the maximum complexity that system can reach is the complexity that individual at the top can oversee and strategically delegate and coordinate, right? So there's a limitation to the amount of behavior we can expect from any given organization in this idealized form. Obviously today it's not like one is at the top and he plans everything in his head and it goes all just down and they execute, but it's rather we have some more lateral connections, right? We have some departments that are connected, and this is more like we operate today, and this is this hybrid we are already at with our society. So it's some kind of hierarchy, but we have these lateral connections in place already, because otherwise we couldn't function in these big corporations or even smaller corporations, and it's just more efficient. And the system tends to take the most efficient route, and if it has an inefficient route, it just will die, and the more efficient systems will come replace it, right? If you are a company A and you have company B, they both produce the same things, but company A has double the amount of overhead costs, and they have no unfair advantage. Obviously company B will succeed and company A not. This is capitalism, and this is why capitalism is great. So, and in the end this goes to a network state, or it goes to networks, because networks are actually way more capable of handling complex behavior that is just bigger than one single individuum or a group of single individuums could handle complex behavior. So this is some kind of natural process. And the reason for this is basically if we can say an organization or an organism, both interchangeable, and we have the complexity of environmental demands, right? So with the hunter-gatherer civilization, the demands of the surroundings would be a maximum like bears or wolves attacking or another tribe attacking, right? But with more evolved societies and more evolved organizations, we get into more evolved kind of competition. This, therefore, increases the complexity of the environmental demands. And you see already we have some kind of feedback loop going on, right? So if you want to stay afloat, if you want to survive, your organization or your organism has to keep up with the complexity. And the only way for you to keep up with the complexity is to first increase the branching ratio, put in more management position, then increase more lateral connections, and in the end, if the complexity gets too far, you just need the network, otherwise you can't handle this. And this is basically the one way to think about it, why this is an inevitable process. And in a way, this resembles already again the scale of complexity we've seen again, right? This like mirroring itself in this idea of this. So this is now you can look at the human, and this is the civilization scale, and we have here the complexity, and you just see how the hunter-gatherer civilization, early civilization, industrial, and hybrid and networked. I think we are at this hybrid stage, and how our civilization becomes able to, even in the greatest scales, right, like in the biggest scales of like one world or something like this, we have the ability for any complex behavior, right? A world with hunter-gatherers wasn't able to do anything that would resemble a civilization, and part and more we were able to unlock more tiers of collective power, I might say, or potential things we could do and influence. So this is basically all this put together, the historical progressions. We have these structures here again, and then you see the complexity rising, and you see how this moves on a visual level. And this is basically it's a big picture. Then this is going to go down. You see, like now we're scrolling down, and then you have this topology of this, right? So this is the hunter-gatherer civilization again. So there's basically no connections. Maybe there was some war, or maybe a man or a woman met each other and changed tribes, but this is basically it. These are like ancient civilizations. We have maybe some trades between them, but all in all, they are all just for themselves, and it keeps on increasing. And then we get to this more networked place, and I think this resembles our society right now pretty good, like this global connected world. And if you just extrapolate and take your fantasy or your creativity, you can imagine where this can go or where this will go based on this. Yeah, this was entropy as well, right? And I needed to put energy in to repair it again, right? So yeah, and on the bottom you see this thing that's really interesting. So we have the specialization diversity. You all know industrialization, specializations, humans can work together and do more things. But then we get something like these lateral connections. They are actually really important. And as we get those more, the hierarchy levels actually get to a point where they reach the maximum and then they decrease. And this is basically what decentralization is doing as well. I mean, and this is for me what's so remarkable about the study, because it perfectly sums up what is happening right now without ever hearing about blockchain, because this is what blockchain basically does. It reduces the hierarchy levels because we don't need this anymore, and it's more efficient. And a system that is more moving and has goal and keeps on building complexity moves to the most efficient way to handle the complex challenges it's presented with. So this was part 2 about complexity and civilizations. Are there any questions about this?
Yes, this seems to imply that hierarchy has a scale.
Yes.
But there are huge organizations that are hierarchical, like Nestle has 300,000 employees and one CEO.
Yes.
Does it mean that when they do scale, they kind of act like networks? Like you might imagine the departments having agency to work between them or something like that. Yeah, exactly. I mean, this is what huge organizations are doing. They are constantly restructuring and seeing where they, like we had this phase of corporate downsizing that was actually this, taking out the management position that you didn't need at the moment, making it more simple and installing local decision making, installing direct connections between departments instead of going it like these ways. And these are exactly these hybrid structures that a classical hierarchy-born system keeps on evolving in if it has the will to survive, like all these corporations obviously have. But when you see with these structures how there are inherently
träge, like delayed in their behavior, right? You see that startups are way more faster making decisions and doing things, like they can make a pivot like this and turn their business model around 90 degrees and go into a way where they see a chance to profit, right? A corporation needs 6 months and 300 meetings for this to decide before the whole organization comes to a consensus, right? So there you already see the inefficiencies they have to fight with, right? And the idea is to basically take these, take more and more of these jobs that these big corporations do, and either the corporations become more networked, or there are networks evolving that we are in the Stone Ages, right? We can't just make this and replace all the big corporations right now, but this is a process where I think it's quite plausible that we can come to a point where these networks just outperform these corporations based on the theories and the way networks are more efficient than hierarchical structures, basically.
Right, and yet having a leader or intuitively having someone that can take a decision should reduce a lot of complexity. So, like, I'm not completely sold on the idea that hierarchy doesn't scale, because up to a point, if you have many leaders or decentralizations, they have to agree.
Definitely. I mean, I'm with you that there's not decentralization is you should decentralize everything. Like it's like there's centralization where it makes sense because it's more efficient, and there's decentralization where this is more efficient. And for example, even with the network structures, I see that basically a node in the network could be a corporation or a team of people, right? Where you have this one person that has some kind of vision or knows where it's going, and these people are acting together, like in the tribes we started with, right? But through a macro network, right? Through this one connected blockchain or several connected blockchains, we can connect each other and build the kind of structures in a more decentralized manner, where like 10 corporations maybe could fill positions in a specialized manner that like 3 separate bigger corporations were doing, right? But they are more agile because these 10 things can form to resemble something like this if the market needs this, but then 3 of this and 5 of another cluster can form this kind of corporation. And we see already in supply chain trends that the supply chain iteration cycles get faster and faster with the more and more flexible demands the user has to it. Like you can move into fast moving. Consumer made these fast moving fashion for Zara. Look at the success of Zara, how they are successful, and they are a really fast and agile supply chain, right? These are the things that will be the winners of the future. Right now corporations can make this if it's their goal, but I think in the future networks, like look at China. China is one giant supply network of lots of parts, and they can basically produce anything. Yeah, I think does this make sense for you in a way? Or does it help you answer any of your questions? Yeah?
Yeah.
Okay. Yes.
Pretty interesting. So in complex systems, the order that is emerging is actually emerging. So you have this emerging process.
Yes.
And things are popping up in a less and less predictable way as well.
Yes.
And this is in part because of the many connections that exist between all the participants or the people involved in these complex systems. And related to that is the fundamental purpose of human, which is to kind of predict what's going on in their environment. So this is intimately bothering for humans, right? Because if you don't predict, then you don't go through life at ease.
Yeah.
And these touch upon the black swan thing, which is, okay, so where are the novelties happening? Where are they going to happen? And if I can't predict that, then it's more and more complicated to be at ease in your life or to do business or whatever. So with the increase of societies that run on complex systems, is the future not going to be less and less understandable and, we'll be maybe less capable of understanding what's going on, and therefore to actually make society maybe not more efficient, but just as efficient as it was before.
Yeah, I definitely know what you mean, and I have another talk that is basically going into this question. So it's basically the thing is with complexity, it's rather counterintuitive in some ways. Like what we are doing with blockchain is we are basically increasing the complexity that will arise from it, but not through building complex systems, but building, as counterintuitive as it may seem for someone that works in blockchain, simpler systems, right? Systems like new building blocks that we can arrange in a really simple manner compared to what we are doing right now, and therefore through increasing, taking all these things that historically have grown, and with this knowledge we say, okay, this, and this is how it works, and we put a sandbox on top of it, and we take these elements we need, and we recognize that in every of these things, in these economic systems we need, we build new elements, new atomic elements, and then we can recombine them into new systems. And this is where the actual new complexity will arise from. So for example, this will be something like if we, for example, have an open source connected infrastructure for our complete supply chain. There's this thing called transaction cost theory that says if you have 100% of all the information regarding the transactions you want to do, the transaction cost goes to zero. And this basically means if we know all the players and what they produce, at what price, what time, what other things they have on lager, on their storage, right? And then we can make a decision from whom to order and who to deliver who. So we basically can build on top of this infrastructure a algorithm, for example. So then you take basically a CAD model of a car, right? And you can do already, you have this engineering model, this 3D model of a car you can take on your AR helmet, and you see the car real life here, looks good, you can work on it, whatever. And you can say, okay, this is this kind of metal, this is this kind of other material. And you already today can take this model and put it into a program that will take you with quite good certainty what this will cost if you produce it, because it knows already so much about this process. What it just needs is enough data so it can tell you where you have to source your metal, then it has to go there, and there, and you can build you take the goal you want to have. I want this car. You take it in the machine tells you everything you need to know. So the machines and the algorithm we build will make this complexity and abstract it into something more usable for us. Like we have all this knowledge, but we don't have to go into a biblioteca and look at the things, but rather type it into Google, right? So it's a more complex system, but with a layer of simplicity that enables us to interact with it. So I hope the world will actually get way simpler for us, and everything will go to the background, and we won't see this. It's going to become more magic, I would argue. So, do we have questions on this? Okay, so the last thing is now we're actually going to talk about some blockchain. Yeah, and it's the part 3. How do we manage increasing complexity? And this is, so it fits into this. We're going to start with the 2 archetypes of blockchain, right? And the 2 archetypes of blockchain are the regulated, permissioned and private chain and the unpermissioned public chain. Who here knows the difference, roughly speaking, of private or public chains? Alright, amazing. So this is obviously just one way of looking at this. There are many ways you can put them on the opposite, but I want to go something here with it. So let's start with the public chain maybe. So we have 3 entries. Everybody can become a miner, everybody can make an account, and everybody can be of a system such as Bitcoin or Ethereum, as long as you have an internet connection, right? So this is amazing, and this is really good. Laws are codified, or basically laws are in the code, right? laws that govern the behavior you can have in the system are only in the code, right? So with these 2 points, how is it on a private chain? On a private chain, this is something like IBM working with Maersk and saying, we're going to make a consortium, and yeah, you're sufficiently big enough player and you're relevant, come into our consortium, we have this new amazing technology that's going to make everything more efficient, right? So this is great for everybody that's inside this consortium, right? Because now you save 10% on all the costs you would do in international payments or something like this. But if you have to compete with some of this company, but you're not inside of this, this is actually really bad for you. So with private chains, you always have a gatekeeper that says that knows everybody that is participating and handles that is a good ecosystem, right? This has actually some advantages. One of them is that you can have rules in human language. You can write, don't do this, don't do this, don't do this. And you don't actually have the need to find any mechanism design or something to govern this. But you can just say, don't do it. And if you do it, you're going to get kicked out. This is some way of cryptoeconomics as well, because you have a disincentive to do bad stuff, because then you're going to be kicked out. And you don't want to be kicked out of something that helps you reduce your costs, right? So you have some kind of other behavior there. In Ethereum, once you get scammed, maybe it's your property, but you can't do anything with it anymore, and it's gone, basically. There's no really way of recourse. There was this thing like the DAO, right? But it was so huge that the community did something about it. But in general, there is no way of recourse. And this is a problem, because lots of people get burned and they don't come back, and they don't think positively about this. So this is basically like entropy again, right? These people, this is entropy for the system, and it reduces the amount of growth and the amount of people getting into it and staying in there. So we have the consequences for bad behavior, and the system behavior complexity is limited by the gatekeeper or by a more hierarchical structure, because there's always a person or a company that has a lot of power initiating something of this, if this is possible. The thing is, with the unpermissioned public chain, you have the system complexity limited by what can be coded, right? So you don't have the advantage of the human language contracts anymore. But you have some other advantage, like the free entry, and you actually are really inclusive, which is really important, right? Yeah, so we have black swans here that can be a problem. So now we're going to introduce governance. This is a new topic for blockchain, and I think it's really important to talk about it, even though some people don't see it as yet or feel like it's a threat, and it's fine to be critical about it. But I'll always say give everything a fair chance and just think about it and maybe do your own research. So, governance is basically the idea that we can add this layer of... The fallacy is basically to say either we have free entry or we have these human readable codes of behaviors, like club rules, right? Like making it a fair and place where you actually want to be, and make you not feel like you're in the dark web where one thing you do wrong or everything you own is going to be away. This is no thing where you want to interact with on a constant basis. So what we're going to do is actually we're going to make a set of rules we're going to codify in a constitution, in an actual constitution. And if everybody can enter this chain, the chain is public and the chain is transparent, right? So people can see certain things that you should see in a decentralized system. But to enter and to interact with this, with every transaction you do, you sign the constitution. And there are some ways where you can actually have this be legally binding. So you get into this, you make a transaction, and with the transaction, it's like terms of service, right? Terms of agreement you sign. You go into there and you basically say, I won't behave badly. And if I behave badly, I am okay with being held accountable for my bad behavior. Because these are some rules you need if you want to get to mainstream adoption, right? So we have this constitution, we have an intent, the intent is always really interesting, like with the mechanism design, right? You have this with game theory, and then you have the reverse game theory where you get to the mechanism design, right? You always have an intent where you want to go with the mechanism that you want to reach, and it's hard to really know that the things you do will have this certain intent, right? Because you never can know. So let's imagine I'm going to write a smart contract with a certain intent on this chain, and it turns out the smart contract has a bug or something like this. So the way this is built on a governed chain is that you combine the smart contract with the human readable contract where you write down the intent. And in case the smart contract, the code, is going to behave in a way that doesn't resemble the intent, like through a bug or some misprogrammed mechanism, then you can always, you have some kind of course of you have a way of changing this. And this is basically what's called arbitration. So, do you know what arbitration is? We already have this in this word, right? If you have CETA or TTIP, then they always have to discuss where it's going to be this arbitration court in my country or in your country, and it's going to take a really long time. But in a way, arbitration is just saying two people agreeing that if they come to a problem on a certain topic, they opt for an arbitrator or a pool for arbitrators in advance, and they say, okay, these arbitrators will decide what was the intent, how should this be resolved, right? So in case that you get scammed, you can maybe you lost 10,000 euros or something like this, right? So it's too much for a complete chain like Ethereum to fork for you to get your 10,000 back, even though it would be the right thing to do in a way. But with arbitrators, you can go, and if they have certain permissions or privileges on this chain, then they can actually see this. Then you take the evidence from person A and the evidence from person B, and an arbitrator always wants to make a fair agreement where both agree this is fair, and then he says, okay, you have to pay this amount back or something like this. And this is actually really genius because, on this slide, I have to, how do I make this in a coherent argument? Let's just go to the second point, right, for this. 99.99% of the transactions on a governed chain are handled by the code and the blockchain, right? The blockchain is, in a sense, reading the code and acting like the code wants it to act. And it does the major part of these transactions full automatically with really low cost, right? But in the case that one transaction doesn't go that well, we can have actually a human element. We can have a human that reads the constitution first and foremost and says, okay, this is what we all agreed on, and then he reads the contract and says, this was the intention of the contract. And then he can see, okay, this didn't work that well, but no problem, we can just, here's your money back, this goes there, and whatever. Like, if you think about smart contracts like robots in a factory line, a robot can have a bug, a robot can have a problem, right? You should just be able to take the robot, either turn it off or put it out of the factory line, repair it, and put it back. And you shouldn't have this robot going mayhem for the rest of eternity in there, right? Or no thought of doing this again. And this is a way where you can do the things that he did wrong. You can recover is the word I was looking for. So these are a few parts of this thing. I don't want to go into much detail, but just so you know, so this is basically the unpermissioned blockchain, right? This is something like Ethereum, Bitcoin, and this is a regulated permission chain, like Corda or Hyperledger or something like this, right? And what the governed blockchain is basically doing, it says, well, it doesn't have to be this or this, right? It says the fallacy is the wall. The wall, the gatekeeper, is the problem. The real requirement is free entry. In this way, through this constitution, through this government processes, right, it enables a community to have its rules of behavior, right, but still be free of entry and don't exclude anyone, which is really important if you want to do something meaningful. And so this is the really interesting part why governed blockchain should be considered in the future. And think about this, you are a hacker now, yeah? You have great abilities. You can basically hack everything if you give it some time and some Red Bull. So there's a fat contract on EOS, one of the governed blockchains, and one on Ethereum. So right now, you could hack it on the governed blockchain or on the ungoverned blockchain. If you hack it on the governed blockchain, the other person can file an arbitration agreement, your wallet will be frozen, and the block producers can enforce this arbitration ruling to give the money back. It's like in our civilized society we have, like there's a way of recourse. But on the other thing, it's yours. No way to get it back. It's yours, basically. You can do with it what you want. So where are you going to go? Where will the hackers go? The hackers will tendently go to the chains that don't have governance. So you have some way of incentivization that will lead to better behavior. Just the threat of this could happening will lead to a better behavior, right? Because it's more it makes more sense for a hacker to go somewhere where he can keep what he steals.
I have a question. Oh, later.
What? The question, yeah, please.
What if governance itself has a bug?
Yeah, so this is basically the challenge in every system. So the challenge with this system is so you can be kind of sure that you have alignment of interest like in every other protocol, and basically create systems where you don't end up in a situation where one is basically controlling all of these things. But there are quite good mechanisms that help keep some kind of power balance. So we have basically a distribution of power in three systems that are the block producers, the arbitrators, and the community itself. The community can vote through referenda, right? So we have checks and balances in and of itself in the system. So of course no system is perfect and every system can fail, but this system has good methods of recovering from this failure, and it has good alignment of interest. So even if you control everything, if you do something obvious with this control that doesn't make it seem like it is uncontrolled, because if it behaves like it's uncontrolled, we actually don't care, then people will move away, fork, or make you can actually, as a community, you could go through and get a referenda through if you have enough voting power, let's say, and rule out certain behaviors and kick them out of this as well. So yeah, this is actually a really important question that applies to every system in the end. So I think we can't make it like we cannot make it we cannot be 100% sure that there is not one super whale that's controlling 51% of everything, but we can design the system in such a way that any bad behavior, even of somebody having this kind of absolute control over such a system, will be noticeable. And yeah, so it's harder for this system because you don't own in something that has simple proof of stake, for example. You just need lots of money. Here you don't only need lots of money, but you need like spies and people that find out about certain people that are anonymous, about arbitrators, and then go out, kidnap their family or something to you have to have, if you really want to take over the system, right? You need some way of having power over these people, right? So it's not only economically but social and on a huge scale, best case. So you have to make it basically in front of the whole community. Of course, nothing is impossible, but it's quite hard in a governed blockchain because you have these several systems of different kind, andersartig. Sorry, it's yeah. So this is basically the idea. We have the community, we have the intent in the community, the constitution as one layer, and then we have the referenda that can be that can be voted on by the community. We have the producers. I haven't talked about the consensus algorithm, for example, and we have this arbitration, and this together makes a good or new kind of system with a more flexible behavior and a way for itself to self-correct. So the governance system enables the system to better function as intended. We had this with the transactions. We have a lesser degree of failure. Users stay longer, network grows faster, e.g. it's a fitter system. Yeah, 5 minutes, yeah, okay. Then yours is Yeah, well, I can talk a little bit more on EOS specifically because it's one of the big contenders for a really good governed blockchain. So the really interesting thing why I came first to EOS was actually because it's focused on developer and user experience. Really, it wants to get this mainstream adoption going, and they know the things that are important for it. The founder says EOS is the blockchain to build decentralized applications that won't be distinguishable from centralized alternatives. So you won't even know that there's a blockchain operating this. You don't need to know. What is the decentralized app? Think Uber without an Uber company operating it. Sounds efficient, it is. This is how these platform models all work. Like you have the value creator, you have the value user, in the middle you have the central server, and you have profit extraction. You get some problems with these kind of systems. You get basically misalignment of interest, right? We have the beneficiary, we have the user, we have the profit. They don't have all the same interest, right? Profit is the only reason for service, right? You don't want to give the user the best service and the best experience. You want to give him that amount of experience that will reach make the user sufficiently happy so he stays and doesn't leave and costs you the least so you can maximize your profits, right? And the user doesn't have any real interest in your company succeeding or not. You're just another service provider, right? And what does a DAC need, a decentralized application? It needs no direct transaction costs. This is one of the biggest problems with Ethereum. I really like Ethereum, what it has done for the community, but one problem, if you aim for mainstream adoption, which I don't even think Ethereum is actually doing, you can't have transaction costs. Even if it's a microcent, we humans have a cognitive bias in our head that if you spend something, you try to minimize the amount of spending, and certain business models like a social network can't work because you have to interact with the software for free. And then you get the content creates the value, and then you can have values, and then the business model works. But the precondition is free transactions with the system. You need good user experience. User experience first is what we have learned in in 2010 and upwards, like from Apple and everyone else adopting it, really successful. If you don't do this, you don't have a chance for mainstream. No fancy crypto stuff. It's a problem that our names are these long hashes. Nobody can work at this. It's really hard to verify that you're interacting with the site you need to interact with. You need account recovery. If I lose my private key, my money is gone. If I don't have a copy. If I lose this, for example, on EOS, there are ways of recovering it. I basically can, if I identified myself before I did this, I can go to, for example, to a person like an arbitrator, and he can recover, he can verify you are this person and recover it, or you can have, this is already like done with some additional Ethereum stuff, like where you have 5 friends and they say, okay, you are this one. User data protection, access to other blockchains, bug recovery is really important. So I have to speed up, right? So this is basically what a DAC looks like, the decentralized autonomous corporation, right? These are the networks I was talking about, right? These are networks without a hierarchical person on top or something like this. These are open source codes where we have a community or a network of people that resemble something like a corporation and do their jobs, but without the profit part, right? And we have the value creators and we have the value users. Of course, you can hold the tokens and hope the tokens go up in liquidity or something like this. Through you holding the tokens, you provide the ecosystem actually with liquidity or capital. So therefore, you are part of this and you have vested interest in these kind of things. So an interesting part is that you have now alignment of interest, right? You now not are just the user, but you are a shareholder as well. So it's not shareholders and users, and the shareholders have the power, the users don't. And they decide everything. It's more like this. Shareholders and users become one and the same persons. And decisions now not only try to maximize the profit, but they can be like let's minimize the profit and make it like more cost less for us and make it a better product. These are decisions that are actually able in a system like this. How does EOS work? This is really important, but EOS has a really good shot at mainstream adoption. So this is how I'm going to keep referencing Ethereum because it's the industry standard, and this is how you build an Ethereum DAC. You basically have Ethereum on the bottom, it's the computer, it's doing the calculations, and if you want to do anything, you have to build an application on top of it. But the thing is, you have to do all the things like user management and other stuff. You have to do them on the application layer. And this is a little bit like building an app for a smartphone without having Android, right? Because there are lots of functions all the apps have in common that you should have in an operating system that provides them for you. This is why EOS says it's an operating system, because it has certain functions pre-programmed, like user management, account recovery, two-factor authentication. You can use your iPhone. For example, iPhone has some hardware key on it, so you can make your iPhone to a actual good wallet. And all these things are pre-programmed there. And for a developer, you just have to take these elements, and then you can focus. So they do a great developer experience, so the developer can focus on building a good user experience, and this translates to a good user experience. How does delegated proof of stake works? This is, I don't think we have time for this. These are 5 aspects that make it great, because now I'm at the point, this one is German, where I talk a bit of EOS. So it has amazing performance. So they use they program the smart contracts in C++ and compile them down in WebAssembly. WebAssembly is the standard that Google, Facebook, Microsoft, and Apple and all the big companies are using for a good reason. This should step into the place of something like JavaScript and operate in the front end, be very fast. And with this, you actually have the smart contracts in WebAssembly, and this works really well. They get, without optimization, to something like 50,000 transactions per second, and it can go to a theoretical limit, because this is technical stuff for who is interested, because they don't do consensus on state, but they do consensus on messages, and then they can scale to something in theory like 3 million transactions per second with something like block times of 0.5 seconds. And 0.5 seconds on blockchain that is across the world is actually at the limit of what's physically possible, because the light has a certain amount of speed you have to count in. And so in a way, EOS, once it's running, it has 21 block producers. That's really lean. It's like a particle accelerator that's shooting a trust particle around the Earth and operating Earth systems with this. So yeah, BitShares and Steemit are 2 projects that already do more transactions per second than Ethereum and Bitcoin together combined. Both of them were built by the lead developer, Dan Laramire, who is building this. Dan Laramire and Ian Grigg is working on this. Both are like blockchain heroes or something like this. They are really long in the field. They worked on this before there were blockchains and decentralized technologies and legal stuff, and they are really some of the leaders in this field. There are some leaders as well, but they are really good. Here are some people that are behind this. They have like 1 billion in capital. They are now reinvesting into projects and companies. So they say, instead of you doing an ICO, you can have like money, and then you take some of these tokens and you airdrop these you give them basically for free to the people holding EOS. So this is a really potent feedback loop for this to get more value. And because the whole ecosystem doesn't need any miners, they just have supercharged computers that don't need to do these mathematical hashing and burn lots of energy and produce lots of cost. They just need to make blocks fast. They have lots of this money. For example, Bitcoin has like 5% or 4% inflation, Ethereum 11% inflation per year. They need to finance themselves and the network. EOS takes this money, needs to spend like 0.1% or 0.5% on the actual hardware part, and can take all of the remaining of this inflation to do meetups, workshops, education, right? You can take this and you can actually make free programming courses for your ecosystem. You can incubate new projects. You have to imagine what kind of value this brings to such a network if you have such a system in place where you can take something that is something like 5 billion in valuation right now and do something like 5% inflation on that, take this money and reinvest it in the ecosystem. As long as the return on the invested capital is higher than what you took from it, it's going to be net positive for all of the system. So it's a really, really potent feedback loop they implemented, and they have some money to burn to kickstart this. So yeah. This is just for the end of the presentation. OpenTelos is the company I am building right now. OpenTelos is, in a way, a startup, but we don't say we are a startup that builds this product, but we say we are rather a value-driven, dynamic startup. OpenTelos, telos is Greek and means goal. So we have goals, and they are quite long as well. But why open? Because we want to show, or this is for us to keep our mindset always that with new knowledge we will change our worldview and adapt the goals. For example, if we see we are doing something bad, or we thought something was good and then we get some new knowledge. So this is really, for us it's important to, the values are the most important thing, and after this comes the doing. This is a different approach, but there's not that much on the internet, but maybe you will hear from it again, hopefully. Yeah, so this was the presentation. Thank you very much for your time, and if you have questions, you can ask them now.
I don't know if you have questions, but the problem is the time. We can go also outside and have a drink, and then we can discuss. Or is there any previous question, and then we can make it maybe in 2 minutes. Someone has one single quick question? Your questions are never quick.
No, but it's just that.
Okay, 4 minutes.
So the point about online governed blockchain or online governance. The main intention from Vlad Zamfir from Ethereum is that in doing so you reduce at least one layer of taking decisions. In this case, that would be the nodes deciding not on implementing a new version of the protocol. Do you see this as a problem in EOS?
No, definitely not. Especially if you think about how big the pools got in Ethereum or Bitcoin or something like this. So I think it's actually a problem that the nodes are deciding what will happen and not in the end. So that the Ethereum network, who owns it? It's the miners, right? So I mean, I'm not sure, it's like 3 or 4 mining pools need to collude to have more than 51% and can decide basically everything, right? And yeah, so this is a problem, and they will stay the miners. With this, they have another consensus mechanism I didn't explain, but it's voted, right? So if you are a miner and you do something that maybe the community doesn't like, that you can be voted out in the course of 1, 2, or 3 days and lose your right to mine. Therefore, your incentive is to do good things, but you are not the one deciding on your own. You have the power as miners to change the chain and do certain things, but you should only do so if you are certain that this is in the sense, in the intention of the behavior that is expected. Otherwise, you run the risk of getting voted out and losing the source of your income, which could be devastating for you. So you have a quite good interest in behaving good in this process, while classical miners don't have this because they sit on their hardware and they don't even have any cost. So there's proof of stake, you have Slasher or something like this. This is nicer, but yeah.
Yeah, just as part of picking up on the thing about governance, it's almost a little bit contradictory to what I regard blockchain was in the first place,
yes,
which is getting rid of the middle person. Okay?
Yes.
But it's kind of weird because it's not a criticism, but you didn't mention things like reputation and credibility, because if that's built, if reputation and credibility are built into the system, then isn't that a way of introducing the concept of self-governance?
Yeah, it is actually, there is a concept of reputation. For example, the arbitrators will have some kind of arbitration, some reputation, and the block producers as well. So the reputation, but you don't even have to model it on a level, but it's enough if it's information in a collected consciousness, right? So if you are known that you are good behaving, value producing, always hardworking block producer, then you have good reputation, and you don't even need a reputation score representing it. You just have it like natural evolving human reputation in the system. So there is this element, and I think for arbitration, lots of these things are subject to change because it's still in development. Will launch in June. Yeah, you will have reputation as well. And self-organization is exactly the key word. This is an interesting part. This is about self-organizing systems that can upload, and you can update the constitution as well. So this system is really flexible, even on a macro scale, on the behaviors it can have, even if the environment changes and gets more complicated, it can have this self-reflection process and then adapt to these things. So self-organization is the key word, yes. Okay, yes, thank you very much for having me, and thank you for your time.